Hi, everyone. My name is Berk Geveci, and I lead the scientific computing team here at Kitware. And so today we're going to, Sankhesh is going to cover the new features introduced and changes introduced in VTK 9.5. I have the pleasure to start the presentation and give a brief non-technical introduction to Kitware. And after that, Sankhesh is going to continue with the technical part of the talk. So one thing I want to mention, if during the webinar you have questions, please put them on the chat interface on the, in my case, it's on my upper right of my screen. And during this webinar, we're going to take breaks and try to answer those questions. And if there are ones that are really relevant, I may interrupt Sankhesh at that point also to pass him to that question. We will also stop for a few questionnaires. When those start happening, Sankhesh will introduce them and give more specific information. Now you can move to the next slide, Sankhesh. So Kitware is a leader in scientific software in AI research and development. We work with government agencies, industry leaders, and academic institutions to tackle complex challenges in various areas, including computer vision, medical imaging, scientific computing, and high-performance software systems. Sankhesh and I are more on the scientific computing and high-performance side of things, where Sankhesh also works on the medical imaging side. So our mission at Kitware is to build cutting-edge open-source tools that accelerate discovery and empower innovation. We have over 150 engineers, researchers, and developers, and we're spread across 6 offices in US and Europe. The one that Sankhesh and I are in is in New York, actually in the capital region in New York, but we also have spaces in North Carolina, New Mexico, Virginia, Minnesota, and in Europe, Lyon, France. We have a distributed collaborative culture, and this culture helps us deliver impactful solutions on a global scale. At the heart of our philosophy is our deep commitment to open source. We believe in building sustainable platforms that bring communities together, platforms like Tram, PeerView, and today's Spotlight VTK. These tools don't just solve problems, they encourage collaboration, accelerate progress, and form the foundation for the next generation of innovations. As I mentioned before, we are a highly collaborative company. Our largest research efforts are generally funded by the US government and involve many commercial and academic partners. We're also involved in many smaller research efforts. We perform custom application development, and we provide support and training on our open source platforms. Our areas of expertise span energy and manufacturing with a focus on simulation workflows, high performance computing, scientific visualization, and data analysis. We also work in healthcare and life sciences with a focus on digital pathology, surgical planning, medical image analysis, medical visualization, and bioinformatics. For our defense and intelligence customers, we work in visualization, data analytics, image and video forensics, threat detection, and activity recognition. We heavily rely on deep learning for a lot of our work. It's a big part of what we do, and we have a strong emphasis on ethical and explainable AI. So that's a very quick rundown of sort of what Kitware is. And now Sankhesh is going to take over. Sankhesh is the leading developer of VTK. He's done many contributions. One thing I want to repeat before he starts is that for those that joined later, is that during the webinar, we're going to take breaks to answer questions. If you have questions, use the chat bubble on the upper right to type your questions, and we will either take a break to answer questions, or If necessary, we will also take breaks, in the moment to try to answer questions. We will also have a few questionnaires, and Sankhesh will introduce those when the time comes. So with that, I'm handing it to you, Sankhesh.
Thank you, Berk. Good afternoon, good evening, people on the other side of the globe. So, as Berk mentioned, this is the 5th minor release of the 9th major release of VTK. And I'll be going over some of the improvements. Even though it's a minor release, there have been quite a few additions and feature additions to VTK, including like a core modernization effort. So it's a software toolkit at the heart of it, as well as some improved enhancements to rendering. I'll be demonstrating some of the rendering capabilities as well. As well as some of the I/O abilities of VTK have been improved. Some fixes to data modeling and filtering, and VTK's Python support got some improvements as well. So I'll go over all that during this presentation. But before I do that, I just wanted to give a brief timeline of how we got to where we are right now. So back in 1993, 3 engineers started out writing a software toolkit which was sort of labeled as a software companion to the actual book that they were authoring, which was based on an object-oriented approach to visualization. A year after that, they published VTK as a software toolkit for processing and visualization of large data sets, and it quickly gained traction in the scientific and medical communities. Fast forward 24 years later, in 2017, the 8th major release of VTK made its way out with improved C++. So that was the first release that made C++11 the minimum standard, which introduced advanced capabilities like lambdas or the auto keyword to VTK. It also added a few OpenGL rendering side of things, enhancements as well, and also introduced GPGPU programming as well as many core programming using the abstraction layer called VTKM. Since then, it went through a few minor releases, and come 2020, we had the 9th major release of VTK, which introduced a modernized build system to kind of make it much more easier to split up VTK into smaller blocks of data sets, as well as some enhanced OpenGL rendering capabilities that introduced some mappers to VTK for mapping some advanced data sets into different mapping layers, as well as it revamped the Python wrapping system. A few minor releases later, the latest stable release was VTK 9.4, which was introduced in November 2024. That's when we made the commitment that we should we would have at least or at least try to have tagged releases of VTK every 6 months from then on. And so far, we are trying to stick to that timeline. So that's kind of working out. And here we are, VTK 9.5. The current, as it stands, we have VTK 9.5 RC3 tagged as of last night, which from all looks of it, it looks like it's going to be the final cut of VTK 9.5.0. And in general, we are continuing to evolve towards the goal of providing better tools for scientific and medical visualization. So the very first, the biggest change that was introduced in VTK was the C++17 requirement, which not only raises the minimum standard for C++, but also introduces some of the allows VTK developers to use some of the enhanced features of VTK, like the file system support. So you can use the C++ file system library. Or the string view, which allows you to access strings or character arrays without actually making a copy of those strings, as well as the optional keyword. Of course, with this, that means that the minimum required compilers the versions of the minimum required compilers have been raised. And I'd like to preface this by saying that there was a lot of discussion on this course, and community poll was carried out before actually making this change, before raising the minimum required version, so that to ensure that there is community interaction, as well as making sure that there are no significant roadblocks to increasing the minimum standard. So with that, I'd like to take a brief poll here before going over all the different features that were added, or improvements that were added. Is which new feature in VTK 950 are you most excited to use and see? Is it the I/O performance improvements? Is it the rendering framework, specifically the Inari rendering framework? Is it seeing more and more WebAssembly support in VTK for browser-based visualization? Or is it the OpenXR implementation for AR and VR environments? Please go ahead and launch the poll. And of course, the basis for this poll is that we'd like to gather what the community is looking for, so that more and more targeted development can happen in the areas that the community is interested in. So as it stands right now, it seems like the clear topic of interest is WebAssembly and webGPUs, which is, and it makes sense, being able to write portable code in C++ that can then be ported over to browser-side implementations. And then there is an even split between Inari rendering for high-fidelity graphics, as well as AR/VR support for OpenXR. So I'd like to go into some of the details of what new features were added to VTK in this minor release. Well, the first and foremost, we have high-performance label mapping. So folks will be aware that there is already a VTK label data mapper, which essentially allows you to map individual text labels to different points of the dataset. By default, it uses a single texture per or a single GL texture per different label, which inherently makes it slow if you have large number of labels in your view. The fast label data mapper actually uses GPU acceleration and uses a single texture for mapping all those different labels that are user-facing to improve that. So here's a quick demo of that fast label mapper. What I did was I loaded the famous cow data set, and for each of the points on that cow data set, I added a text label. Labels are random, but it turns out that I have 2,903 labels being rendered in this view right now. And with the original VTK label data mapper, this was the VTK label data mapper, I was getting a frame rate of about 2 frames per second with each frame. And then when I switch to the new fast label data mapper, I'll have to go back and try it again. It's anywhere upwards from 60 to 120 frames per second. The same amount of labels and the same number of points, the same exact data set. And I also went ahead and tried if I can switch to actually give a live demo of this. Share something else. So this is a volume rendered view. Here, let me turn off all the labels. This is the aneurysm data set. So I'm actually rendering it using a hardware accelerated volume mapper. And then for basically, I picked a few points along the data set. I believe I have about 300 points being rendered as labels right now. So in this view, just to give you an idea, I have a volume rendering going on, volume mapping going on, as well as these 300 or so labels being rendered. And as you can see, I am getting an interactive frame rate of about 120 frames per second. Bear with me while I switch over to my presentation again. So that was a new addition in terms of mapping. We also have a new introduction to VTK for grid axes. For folks familiar with ParaView, you already know that there is already a data axis grid in ParaView. It's a top-level option that allows you to represent an axis grid around your data of interest in ParaView. That has been ported into VTK with a few bells and whistles added to make sure that it works across all the different VTK applications. For people familiar with Cube Axis Actor, it was starting to get clunky. This is a new way of doing things. It adds it basically uses VTK Axis, the canvas-based Axis support for rendering much better fidelity label placement, as well as there are options for turning on and off faces, as well as interactively hiding faces. Let me go ahead and give you a demo of this as well. So what I have here is actually the data set in question is simulating the airflow around the heated spinning disk. What I did was I passed the data set to a streamline filter to actually get some streamlines and then color mapping. And then I enabled the new data axis grid actor. As I interact with my data set, you can see that the grid is refining itself to make sure I get a much better view of it, as well as the label placement is much more finer, as you can see. I can go ahead and turn on face hiding now. So as you can see, now the front face is being dulled. The other thing that I wanted to demonstrate is it has the ability to label only unique edges, so that I don't end up with labels. The labels don't get duplicated over all the different axes. So I just went ahead and turned on all those options to give a much better representation. So as I interact with my data set, I get those individual faces being turned on and off or culled away. The same grid resolution, grid refinement keeps happening, so I can interact with my data set. There is no, I don't lose any valuable pixels of the rendered data set in question.
Sankhesh.
Yes.
There are two questions. One is asking what is the class name for this axis actor that you're demonstrating?
Good question. It's VTK Grid Axis Actor 3D, and it's actually a family of classes. So a new module was introduced in VTK called Rendering Grid Axis. You'd have to, if you have a VTK application, you'd have to enable that module. But the family of classes that I mentioned, right now what I'm demonstrating is called VTK Grid Axis Actor 3D, but each individual face of the 3D axis is a class called VTK Grid Axis Actor 2D. So you can imagine that if you have, if you'd just like to see a single face of it, you can directly use the 2D actor class.
Right. And then another question was asking in the previous section where you were talking about the labeled mapping, somebody's asking if you could provide a little bit of more detail about the data set that was used there.
Oh, sure. Let me quickly switch back. So this data set right here is the aneurysm data set. It's actually demonstrating, it's a medical data set where it's demonstrating a bunch, it's a CT scan of the, I forget which area of the body this vasculature belongs to, but you can see that there is an aneurysm in this data set. And what I'm doing is it's actually a a volume file that is loaded in as a VTK image data, and I'm using the VTK GPU volume raycast mapper to volume render it. And then as far as the labels go, I basically passed it through a mask points filter to just come up with a sample distribution of points in the data set to give me random points. And then for each of those points, I'm creating some random labels. And if I quit this and share my presentation, the data set in question here is the cow mesh. I don't exactly know the source of that, but that's like a common sample data set and used in I think it's available as part of VTK external data as well. A lot of VTK tests exercise that data set. So if no other questions on that, I'll go ahead. webGPU support in VTK continues to advance. webGPU, at this point, webGPU is a misnomer. It essentially allows us to use webGPU, the GPU access. Actually, back up a little bit. So webGPU is an abstraction API over all the different graphics APIs that different platforms use. For example, Windows, Microsoft uses DirectX, Direct3D. Mac OS uses, or Apple uses Metal as its graphics framework for interacting with the GPU. WebGPU is an abstraction over all that. It was primarily written for the web, for web browsers, but it has since matured into native graphics API as well. And VTK has introduced an experimental backend for WebGPU so that folks can use their existing pipelines and render to a WebGPU-friendly environment or a browser in WebAssembly. So as of right now, we already had the VTK polydata mapper exposed to WebGPU with some of its features exposed. Lately, in this release, VTK Glyph 3D mapper has been exposed as well. And then the polydata mapper 2D is exposed as well. Just to give you an idea, polydata mapper 2D is essentially doing the same primitive mapping as the polydata mapper, except that all the coordinates are in display space. And then a nifty bit of information was added. So now WebGPU has the capability of giving you a memory audit of where all the memory has been allocated and being used in VTK. On the realistic rendering side of things, VTK's PBR, which is the physically based rendering model, has seen improvements in this latest release as well, specifically related to lighting. So now it supports directional as well as positional light sources. Directional lights are lights that are placed at infinity, and you can assume that the rays of light are basically falling parallel to each other, or are orthogonal, parallel to each other as they hit the subject of interest. Whereas positional lights have a fixed position in 3D space and they form a conical view space. So in the image on the left, I have a directional light that is illuminating all the spheres, as well as a positional light right like at the bottom lower right in front of one of the bottom lower spheres. So that kind of you can see a reflection of that light in some of the spheres. So this mixing of directional and positional light, those calculations have been now fixed for PBR, and the result is a more accurate, realistic visual. In VTK 9, we added support for hardware accelerated volume rendering for rectilinear grids. Originally, it only supported VTK image data, which is a uniform grid, but now we added support for rectilinear grids, but then it had some issues specifically related to cell data, as well as some indexing issues in there. Since then, everything has been fixed, and I'm happy to report that if you have a rectilinear grid data set output of your pipeline, you no longer need to resample it to an image data for actually hardware accelerated volume rendering. Everything seems to be working. Some other improvements that were added. So VTK property for the longest time had a line width property that allows you to, for any lines rendered in as part of that VTK actor that the property uh, is assigning material properties to. Those line widths could be controlled via that line width property. But then it also had some other kinds of lines, called specifically edges of your data set, which you could enable or disable via a Boolean called edge visibility. So now there is this break between the two where you can specify a separate width for those edges as well as a separate width for those lines. By default, there is also a new parameter introduced in VTK property that ensures that it follows the same behavior as before, which is edge width follows what the line width is set to be, but you can disable that and then set those two different values independently. VTK Light widget, which is a nifty widget for interacting with lights in your scene. It was exposed in ParaView as well, and in general in VTK, you can modify where your light is in the 3D space, as well as where it's pointing to, what the conical angle is, etc., etc. All that was exposed on the OpenGL side of things. It has since been ported into the path tracing side of things as well. So VTK is an RE implementation, Osprey implementation, all those implementations can now render the light widget and let you interact with it in real time. Multi-light shadow map. So VTK has a shadow map pass render pass. It used to just work for a single light source. It has since been upgraded to make sure that any number of lights in your scene are supported. The composite polydata mapper used to respect only the opacity set or the opacity value set on the VTK actor that it is mapping. A new property was added in there to ensure that you can now set opacity per individual block. So say you have multiple different blocks that you're rendering as part of this composite polydata mapper, and you want to control different opacities for each individual block, you can now set that, and it overrides what the actor's opacity was. Moving on to, so that was all the rendering and graphics side of things. Moving on to the data handling and I/O. The first thing is so scene importers in VTK, which is like essentially coming I/O for reading for graphics. VTK saw a bunch of improvements to GLTF. A lot of the readers have been improved via either their multi-threaded nature have been improved, or they have been multi-threaded so that they see improved performance. And then VTK's NetCDF has seen significant updates as well. Before we go on to that, we have another poll question. So in this question, we'd like to know how you use VTK in your applications. Do you use it for primarily desktop applications, or do you have web-based visualization applications? Do you run it on HPC clusters, or whether you have AR/VR systems that you use VTK for? So please go ahead and enable the poll. And of course, this kind of gives us an idea as to where the targeted approach is. So it seems like right from the get-go, most of the applications are for desktops. The web is soon increasing. And that's where a lot of effort is now going into making our graphics API or the rendering side of things more portable, so that you write code once for the desktop side, and that can then be easily ported via WebAssembly to your web browser applications. So say you have an application that's working on the desktop, and tomorrow you decide to expose either a lean port of it or that into on the browser. Yeah, WebAssembly lets you do it. So thank you. That's really informative. That a lot of the VTK applications are still desktop oriented. So as far as I mentioned, VTK has seen importers and exporters. GLTF is Kronos's GL transmission format, which lets you import a scene or export a scene for other graphics libraries. That GLTF importer saw significant improvements specifically. So say you have a scene already loaded up in memory, you no longer need to write it out and to be able to load it into VTK. You can directly load it from a memory stream, as well as you can now load parts of the data set. So you say you have animations in your GLTF file, or you have some image textures or some skin material properties. All that can then now be loaded in separate chunks, or you can, and as well as toggled on or off depending on what you'd like to load in VTK. So that just makes it much more flexible. As far as readers for different simulation toolkits, they saw many different improvements, like the OpenFOAM reader. OpenFOAM is an open source CFD simulation software that's widely popular. VTK's OpenFOAM reader saw multiple improvements in terms of multi-threaded reading. So now multiple different case files can be read in a multi-threaded manner, as well as case files on network drives. Large cases, it sees improved support for that. The Ensight reader can now read really large binary files at a much faster frame rate, as well as it has improved cell creation for n-phase tetrahedral cells as well. The AMReX particles reader as well as writer has been improved so that it can load up more files larger than 2 GB files. It was a memory limitation because it was using I believe it was using a 32-bit format. It has since been upgraded to a 64-bit format, as well as it can now continue reading, and it no longer seg faults when the top-level header is missing. Its MPI capability has also been fixed, so that it was always so you could have your MPI process kick off loading of AMReX files. But then there was an issue with if there was a mismatch between the number of grids in your dataset and the number of MPI processes. That has since been fixed. Similarly, the append filters have been multi-threaded, so they take advantage of all the different cores of your system. VTK's netCDF support has been improved to add XArray support. XArray is a Python package for n-dimensional data arrays. That has been added to VTK so that it allows you to load many more different kinds of netCDF files into VTK. It has also been improved to, it has been upgraded to the CDF5 format, which is the new netCDF format that was added recently with 64-bit integers, again, adding larger case files, larger file support to VTK. There was a really good blog written about this support, and some of these images are actually from that blog right now. Moving on to the filtering and the visualization pipeline side of things, VTK sees a new implicit function, some new filters, as well as some improvements to existing filters. So the very first thing, a new implicit function called VTK frustum was added, which is essentially, if you look at it, it looks like a pyramid with a clipped top. The idea being that it lets you define an implicit frustum that can then be used for different manipulations. And as speaking of manipulations, you can actually manipulate an implicit frustum via the new VTK frustum widget. There are some test cases as well as examples in the VTK library, software library, if you do a checkout of it. The most simple use cases that come to mind are you can do some kind of advanced clipping or slicing of your data sets with this new frustum shape. The explode dataset filter is a filter that was added recently. That the idea is that if you have a single data set with multiple different regions of data with similar ISO values, it can now be split up, exploded into a single partition dataset collection with many different partition datasets, that each partition dataset being a group of the data. So it's a really fast way of segmenting out different sections of the data or different visual aspects of the data into many different partition datasets. Of course, it uses VTK SMP tools, so it's threaded, and so it's threaded, and it can be useful for, say, if you are loading OBJ groups, you have different materials. It can be all those materials can be grouped independently.
Sankhesh.
Go ahead.
There are a few questions.
Yes.
The one that is related to the frustum one that you just covered
Uh-huh.
um, is is asking if it can be used in tram-based applications. Specifically, it's asking if it's supported with the serialization deserialization API that's currently used for WASM work.
I believe all the widgets have been supported, are now supported, as well as implicit functions have been supported for the serialization, deserialization API. So it should be available on the tram side of things. I haven't tested it, but that's something that I can test right after this webinar and get back to the questionnaire.
There is another question, which is so far is not covered with by your slides, but it's
Mhm.
asking in VTK 9.5, what is the relationship between VTK and Viscourse? And I can answer that question unless you want to take it.
Go ahead, Berk.
So, well, for those that may not be familiar with the name Viscourse, Viscourse was previously VTKM and got renamed, and it's a library that's essentially designed to develop analysis and viz algorithms portably across GPUs and CPUs. The answer to the question is that it continues to be actually the same answer in that VTK uses Viscourse to implement a set of its algorithms that are GPU enabled. You can find the set of the algorithms under, I think it's accelerator slash VTKM. That is the current relationship between the two. VTK does not use Viscourse for its own CPU only multi-threaded algorithms. Those are essentially improvements to existing algorithms that adding threaded support rather than completely rewriting them with Viscourse. So that's the current relationship and continues to be the case. There was another question for which I currently don't have an answer. I actually asked in our internal group at Kitware here to see if I can get maybe Sankhesh would have some idea. I doubt it though. And that the question is when will this version be available as Activist? When 9.5 is going to be available Activist? And I don't think we have an answer. Do you, and Sankesh?
Um, so sort of. So Activist supports VTK master, which means that it should be available soon. I would say there are no real roadblocks to why it should not be available. That's as close as what I know of. Like as far as a scheduled date, I don't know.
Right. If I get an answer while this is going, I will bring it here. But you can also go post it ask it on Discourse, VTK Discourse. You are because the folks that are working on the Activist implementation are in our France office, and it's like 7 o'clock there almost, and so many of them may not be in front of their computers. Go ahead, Sankesh.
Thank you, Berk. So going in the similar vein to explore dataset, a new filter called VTK generate region IDs was also added to VTK. Idea is that you give it a poly data with some similarity, like in terms of cell similarities, etc. It would then come up with connected regions of data. So basically, come up with a new data array that identifies which which regions do each cell belongs to. It's the idea is more like a connectivity filter, but internal implementation is more like the VTK feature edges. So it's multi-threaded. It uses VTK SMP tools, much more faster, a quick way of segmenting out different regions of the surfaces. In addition, a lot of different filters have been improved. So the hypertree grid geometry filter, which actually creates the geometry representation of your hypertree grid, now learned of a new option called the fill material, which is essentially if on by default. If it's disabled, then you'll just see edges of your data set. So it'll just output lines of your the edge lines of your geometry. The probe filter now supports oriented images. A while back, VTK image data was learned a new matrix called the direction matrix that allows it to do non-axis aligned images as well. And since then, slowly but steadily, new and new filters are learning of that direction matrix. The recent addition being the probe filter. The delimited text reader has multiple different features implemented. The most interesting one is the get preview feature to me, at least so I can quickly give it a large delimited text file like a CSV file and just quickly get a preview of the first n lines of data just to inspect it and figure out what are the headers of the file, etc., etc. Moving on to the interactivity side of things. So VTK's QML module learned, QML in general is the Qt's way of creating new applications, specifying new applications. It almost follows like a JavaScript implementation. So it's a declarative UI programming library. And right from the get-go, it was touchscreen friendly. VTK has interactions for touchscreens, but the two never integrated together. So now they are. The way to do it is VTK exposes callback functions that can be tied to the signals that a QtQuick item would emit in a pinch handler. So the code looks exactly, and this is not stubbed out code. This is exactly what you need for these 4 lines that you need for making your QML application, QML plus VTK application touch friendly. So, all you do is you hook into on translation change, on scale change, on rotation change, with the right callbacks that are predefined. And of course, VTK being an extensible C++ library, you can modify those callback functions as well in your own subclasses. The camera orientation representation widget, which is essentially a nifty orientation widget for folks familiar with the orientation marker widget. This widget kind of takes it a step further, where you can actually interact with that orientation widget and modify the camera of the main view. That kind of learned of new symbols. So by default, it was the Cartesian coordinates that were the labels were being displayed. It now has API for modifying those. So for example, in my demo screenshot here, I added for the x-axis, I said that this is where my cow's head is. Actually, I do have a demo for it, a real quick one. So for folks familiar, this is the same cow data set that I used for that rendering labels. So here it is. I have this is the orientation marker. It only goes so far as interacting whereas moving it on screen, but it shows the live orientation. I can use the new orientation marker widget for actually changing the camera. So I can see which axis I'd like to look at, and then now it is configurable. So I have labeled different labels for the different axes. And there's API for specifying the properties, so you can change the font style, font weight, etc.
While you're switching, there is a question that's asking if there will be a VTK advanced course in the future like we have done in the past.
Yes, we are targeting for late summer courses for both beginner as well as advanced. More details should be coming out soon.
Thanks.
So with that, I'd like to know, as far as the future of VTK is concerned, what do you see more? what is the community more interested in? So I'd like to open poll question number 3, please. With the future of VTK, so what area of VTK development is most important to you? Is it more and more performance improvements and improving the scalability, tighter integration with Python? Is it the web-based or remote visualization, advancing WebAssembly, webGPU side of things, or advanced rendering and viz algorithms? And I anticipate this to be like an even split, but let's see what the community. Interesting. So a lot of you folks would like to see the web side of things advanced, and VTK being available more and more on the WebAssembly side of things. Performance improvements remains a close second, as well as rendering. So I'm glad that it does. Do I click close poll? Okay. So I'm glad that we are working towards what the community is looking for. So one final addition and a major addition, so to speak, to VTK is we have been overhauling some of the VTK Python support. And there is an interesting blog that was written about VTK and NumPy, a new take. Feel free to go ahead once you get these slides, click and go over it. But in general, so now you can do, as you can see in my demo code on the right here, I have some Python code. You can actually query the length of my point data, so the number of fields in the point data array. You can query by strings, so if a particular string name is in my point data, and directly get an array of that, which is the name of that data array, by that, or query that data array based by its name. I can go in and use Pythonisms like for field name in dataset.pointData.keys to get access to those, to the various data arrays in a dataset, etc., etc. So Python support. So the VTK is seeing more and more of a Pythonic API, making it more friendly for Python developers, native Python developers. A recent addition, the deprecated decorator was added to VTK. So if you have your Python functions, like toolkits, etc., the deprecated keyword would essentially allow you to deprecate functions and classes, Python objects, etc. And if somebody is using that, give a warning, a friendly warning. So kind of prepares you for when that, then if in the next release it's going to be slated to be obsoleted, you have a fair warning ahead of time. And then the OpenXR and OpenXR remoting modules have now been included in the Python field, so you can quickly do pip install VTK and get access to the OpenXR infrastructure of VTK, the integration of VTK, and have your application directly transmitted to your VR headsets. Some other minor but notable changes and deprecations. VTK continues to use the STL, prefers the STL library, C++ STL library as much as possible. There were some custom implementations of min and max, like the extend splitter class, etc., that have since been ported to using the STL versions of those functions. Hierarchical box dataset has and its similar classes have been deprecated in favor of VTK overlapping AMR. There was this VTK, or there is the VTK typed data array, which is a template class for doing general VTK data array access kind of things, that has since been deprecated in favor of the more mature VTK generic data array that introduces data array agnostic, the type data array agnostic capabilities like set value, get value APIs. And then the OpenXR manager function, some of the functions have been deprecated for because there are functions already existing on the OpenXR render window. So that was more of a cleanup side of things. So at this point, I'd like to thank all the different committers. The work that I presented over that brief span of time, this minor release, was actually the work of 68 different committers over 1,575 commits, which of course, this kind of proves to the health of an open source toolkit like VTK, that you see so many active contributions in various different domain aspects of the toolkit. So heartfelt thank you to everybody. And finally, if you'd like to get a more detailed version of what's in store for VTK 9.5, the release notes will be available at this site right here on docs.vtk.org. It should be available within the next week, as soon as the final release is cut. But before that, if you have any questions, etc., please feel free to reach out, ask questions on discourse. If you'd like to look at some of the documentation, the documentation is always updated with nightly documentation. And then for getting access to VTK, vtk.org/download is the place to be. With that, I say, go ahead, Berk.
Two questions if the recording and the slide deck of this, if they are going to be available.
They are going to be available. Steve is online. Steve is going to be working on actually making that available.
Yeah, so there will be the recording and the slide deck as a PDF will be available afterwards.
Was there any other question?
Not seeing any so far, and maybe we give it another minute to see folks have questions. If not, we can end. I got a message saying that the slides and the link to the recording will be emailed to everybody. Everybody registered. I'm not seeing any other questions, so I think we can wrap up. Sankhesh.
Well, thank you so much. It has been a pleasure going over and highlighting all the different notable changes in VTK in this release of VTK. Of course, it's not possible without the contribution of all the different contributors. So again, thank you.
Well, since we have time, actually, there was a question that I really was not related to the webinar, and I redirected them to discourse, but we have a few more minutes. Anyway, we can answer that. The question is, VTK Stream Tracer allows us to create streamline visualization. Is there a way to see the direction with small arrow on the streamline? I'll answer that question. There is a filter. Well, there are actually two filters, Glyph 2D and Glyph 3D, VTK Glyph 2D and VTK Glyph 3D filters that allow you to associate glyphs, as we call that, individual polygonal data with each point of the data set. And arrow is, you can get arrows with the arrow source to do that. So if you apply the glyph filter on the streamline, output of the streamline, you will be able to do that. There are, as I said, there are examples. If you, actually, I hate to maybe suggest this, but many of us actually do this now these days. If you go ask ChatGPT that exact question, ChatGPT will probably give you a nice code example that does that. But you can also go look in the VTK examples and look for the use of glyph filter to see how it's used.
And I'll add to that. So in addition to glyph filters, which actually gives you an output data set with those glyphs, there is also glyph mappers, so glyph 3D mapper and glyph 2D mapper, that take that data set and just apply those glyphs at the rendering stage. So it's just for the visual representation that you see with the mappers. In addition, the output of that stream tracer will have vectors in the data. So you can basically use those vectors for those glyph filters for actually showing those arrows aligned with those vectors.
I think that's it. That's a wrap.
All right. I'll wish you all the best with VTK 9.5 use.
Thank you, everybody.
Thank you.